Today I also discuss one important proposition related to the topics of measure theory and obviously going to related to measurable set of this measure theory topics. Okay, so measurable sets or known about that if two measurable set then union of two measurable set is measurable. And obviously another properties of measurable set, definition of measurable set we discussed in previous class. Today I also talk about measurable set properties by this proposition. We start now. Here e1 and e2 be two measurable set, then obviously mu star a intersection e1 union e2 equal to mu star a intersection e1 plus mu star a intersection e2. How we prove it? First we talk about it. What is given? Given that e1 and e2 be measurable. So what happened? So we write here mu star a equal to mu star a intersection e1 plus mu star a intersection e1 complement for all a subset of x. We know about that. Again here we write mu star b equal to mu star b intersection e2 plus mu star b intersection e2 complement for all b subset of x. Understand? This one is given. Now what we have to prove? We have to prove, first we write here, to prove mu star a intersection e1 union e2 equal to mu star a intersection e1 plus mu star a intersection e2. So what do we do now? We do now simply here we write mu star, that means this one, mu star a intersection e1 union e2 equal to what? Equal to, we write in this way, equal to mu star a intersection e1 union e2. Okay, intersection e1. If we consider this one is a set, thus mu star a intersection e1 union e2, okay, intersection e1 complement. Yes or no? This is possible or not? Obviously possible. Okay, here we write a, if you write c, not a problem at all. Okay, then if we write here a, then you also change this one. Okay, not needed is here necessary. Okay, anything else you write here. Okay, anything else. So here we talk about this one is c. Understand? So this one is right, then we write this one. Now also develop means what I get from here. I get from here this equal to, write mu star a intersection here we also write e1 union e2 intersection e1. Okay, just this one intersection we write this one first, then plus here in this way we write a intersection e1 e1 union e2 intersection e1 complement. Understand? Not a problem at all. I think this one is okay. So what happened now? This one e1 union e2 intersection e1 equal to what? All unknown about that. Not only this one is just e1. Here e1 in union e2 intersection e1 complement. What happened? Obviously this one is a intersection e2. Okay, okay, a intersection e2. Understand or not? Any problem is here? Not a problem at all. Okay, so I done it. If you do it in this way, then this one is too easy. Okay, but if you extend this one, then here this one equal to e1 and this one equal to e2. If you done this one, then this problem are okay. So first we done this one. What is this problem? This one is important property of set. Not discuss this here, but also discuss here. Okay. Also discuss this one. Then you are obviously that means do it. Intersection E1. You know about that. If you draw this Venn diagram E1 E2, well, union equal to that portion, this one E1, this one E2, then intersection E1 equal to just this one, that means E1. From Venn diagram you also see that. Okay, but we will not use now Venn diagram. So what happened here? E1 intersection E1 union E2 intersection E1 equal to here E1 union E2 intersection E1. Okay, so what happened? This one equal to E1. Same thing E1 and E2 intersection E1. Then union equal to what? This one. Next, where is that portion and going to further discussion of another set properties. Okay, U1 union E2, E1 union E2 intersection E1 complement equal to what? E1 intersection E1 complement union E2 intersection E1 complement. Okay, here E1 intersection E2 complement equal to phi union E2 intersection E1 complement equal to just E2. Then this one is E2. Okay, if you draw this Venn diagram, E1 E2, this one is union, this one E1, this one E2, total portion is E1 union E2. Now E1 complement, this means this portion. Okay, intersection of E1 complement and another this portion, obviously if you draw this one. Okay, but we will not consider, just intersection of E1 complement union this means this one. Okay, understand or not? I think all are understand that portion, but we are not stopped here. What we get from this, or get from this one important property of measurable set. Okay, if to E1 E2 be two measurable set, then what we get? We get mu star A intersection E1 union E2 equal to mu star A intersection E1 plus mu star A intersection E2. This one we get now. Okay, one important result we also get now. What? Now we put this A is subset of X. Now we put A equal to X. If put A equal to X, then what happened? Then we get A intersection E1 union E2 equal to what? Mu star X intersection E1 plus mu star X intersection E2. Then what we get from here? Here we get this one. So simply we get this one. Okay, what is this property? This property is mu star E1 union E2 equal to mu star E1 plus mu star E2. What is this? Finite additive property of mu star. Understand? Now we discuss furthermore. That means here we write about it. Mu star is additive. If 2, then additive. If finite number, then finitely additive. Okay, on n measurable set. Okay, this observation was also clear from that. Now we're going to finite additive property. But first we discuss in this way, it is that portion. Okay, so how we develop in this way, how we develop, we write this proposition now. Let E1, E2, en be measurable sets. Be measurable sets. Okay, then what happened? Then mu star a intersection union of I equal to 1 to n ei equal to summation I equal to 1 to n mu star of a intersection ei. Understand or not? I think understand. Oh, what a problem at here. Now problem is vanished, I think. Oh, what a problem created by someone. Why not create video properly? So this one is an important proposition. Obviously, how we develop it? We first develop union of two intersection A. Then we develop union of n measurable sets intersection A. What happened here? We also see now what happened here. Okay. Now we also discuss this portion. What happened here? Now we also going to prove of that proposition. Okay, so we write proof here. Proof. What we do here, we first do it for n equal to 2. What happened? For n equal to 2, mu star of A intersection U1 union E2 equal to mu star of A union A intersection E1 plus mu star of A intersection E2. Also proved in previous proposition. Yes or no? I think yes. Okay. Then we're going to use of mathematical induction, one of the important tool of mathematics, which gives what? Which gives the proof of more critical theorems and more critical problems. Okay, proved by what? Mathematical induction. Also taught in 12th or 11th standard. Okay, now also this one is in below standard, taught by some student. But this one is an important topic. Okay, so we write here. Now let this above relation true for is true for n equal to k minus 1. Then what happens? We write here this one union I equal to 1 to k minus 1 ei equal to summation I equal to 1 to k minus 1 mu star a intersection ei. Okay, then what happened? Then what we have to prove? This one true. Also marked is this one is 1, this one is 2. Marked it. Now what we do? We do proceed further steps. What is this further steps? We also take let n equal to k. Then what happened? We also see here a intersection union of I equal to 1 to k ei equal to what? We write in this way a intersection union of I equal to 1 to k minus 1 ei into ek. Understand or not? I think understand. Then what happened here? Then simply we do it by 2. No, by 2 no. By 1. By 1 what we get? By 1 what we get? We get this one. So logically this one is still up. This one is critical, but so logically this one is too easy by one. Understand? By one we also write this one. Why? Because we write here union of I equal to 1 to k minus 1 equal to u1 and ek equal to e2. So we write in this way. Understand or not? Any problem here? Not a problem at all. So we obviously proceed further. We'll rest our portion. Yes or no? Yes. Now right here mu summation I equal to 1 to k minus 1 mu star A intersection EI plus mu star A intersection EK by 2. Okay, then we write in this way mu star A intersection EI. Okay, so also prove this result. We now write in this fascinating way. If this one is true for n equal to 2, if the above result is true for n equal to 2, and if the result true for n equal to k minus 1, then it is true for n equal to k. So by mathematical induction also prove that we talk about that, or we says that this result is true for n belongs to n. Okay, then summation I equal to 1 to n mu star A intersection EI equal to mu star of A intersection union of I equal to 1 to n EI. Okay, this one is true. So we also done this problem. So what we prove here? Again we're getting observation from that. Also erase that problem. And what observation we get here? First one we get mu star be additive. And here what we get? So simply, but we write it now. Here I equal to 1 to n mu star A intersection EI equal to mu star A intersection union of I equal to 1 to n EI. Then what we get? We get mu star is finitely additive. Okay, one important property also get from how we get we are not talking about. Okay. Now here what happen? A subset of x, food A equal to x. Then what we get? We get here summation I equal to 1 to n mu star x intersection EI equal to mu star x intersection of union of I equal to 1 to n EI. Okay, then what happened? Then this implies that I equal to 1 to n mu star EI equal to mu star union of I equal to 1 to n EI. Then obviously we do this result. Mu star is finitely additive. Yes or no? I think yes. So next I'm going to further discussion of that proposition. Okay, understand or not? I think understand. Next we talk about this proposition, that means further discussion of this proposition. If E and B is sequence, if E and B is sequence of measurable set, sequence of measurable set, E and B is sequence of measurable set, then what happened? Then mu star A intersection I equal to 1 to infinity EI equal to summation I equal to 1 to infinity mu star A intersection EI for a subset of X. Okay, we have to prove that proposition now. So how we prove it? So logically we develop also. Okay, so logically we develop also. Now we write here, note that union of I equal to 1 to NEI, subset of union of I equal to 1 to infinity EI. Yes or no? Yes. Not a problem at all. We'll let it E. Okay. Then what happened? Oh, we write here for all n belongs to A. Not a problem at all. Then what happened? What we get? So simply we write here A intersection union of I equal to 1 to NEI equal to what we get? Subset of A intersection E, because this one will let E. Okay, not a problem at all. I think for all A subset of X, I understand of set property of this. I think understand, not a problem at all. Okay, then what we write here, we use this property of mu star B monotone. Then what happened? Monotone property, what tell us you? If a subset of V, then mu star A less than mu star B. Okay, then what here happened? Here happened mu star A intersection union of I equal to 1 to N EI less than equal to mu star of A intersection E. Understand or not? Easily understandable. Yes or no? Yes. So we're going to forward discussion of that. Obviously. Now what we write here? From previous last result, or cut this one equal to this. Okay? Less than equal to this one. Yes or no? Yes. Then we're going to forward further discussion of that. What we take? We're taking limit n tending to infinity and to both sides. We get. Okay? So we is our portion and going to further discussion of that. Obviously, mathematics is a beautiful thing. If you're interested in mathematics, then you are known about beauty of mathematics and you are familiar about mathematics. Then obviously you are create interest on SALs. Okay, so not I'll talk about more. I also done this one. Okay, this less than equal to mu star A intersection. Yes or no? Not a problem at all, I think. So what happened? Happen is this. Right here, I equal to 1 to infinity mu star A intersection AI less than equal to mu star A intersection I equal to 1 to infinity EI. Yes, marked as 1. If we write this one, it's better. But if we write this one, not a problem at all. Yes. Next we part the discussion of that. What discuss today? Okay. Next, that means how next inequality we have to prove. Then we are done. Yes. So how prove next inequality? Or first thing about that, then we pass it. Obviously we do it in this way. Note that A is subset of X. Okay. Then mu star A intersection E equal to mu star A intersection union of I equal to 1 to infinity EI equal to what? Equal to mu star union of I equal to 1 to infinity A intersection EI. Yes or no? Yes. Then what happened? Then this one less than equal to mu star. Oh sorry. Here n equal to 1 to infinity mu star A intersection EI. What property this one says that? Obviously mu star be countably sub-additive. So write this one. Understand or not? I think understand. Right here mu star be countably sub-additive. Yes or no? I think yes. So what we get from here? We get from here to easily that not this one. Mu star of A intersection union of I equal to 1 to infinity EI less than equal to summation I equal to 1 to infinity mu star of A intersection EI. Okay? Understand? Marked is 2. Marked is number 2. Then what we get? So easily and so simply. Or write it from 1 and 2. We get mu star of A intersection union of I equal to 1 to infinity EI equal to summation I equal to 1 to infinity mu star of A intersection EI. Okay? Not a problem at all. I think this one is done for all A subset of X. Okay? So we is that portion and going to observation of something. What observation we get? Obviously first we get mu is additive, mu star is additive. Second we get what? Second we get mu star is finitely additive. Now what we get? We write here observation. First we write what we here A intersection union of I equal to 1 to infinity EI equal to summation I equal to 1 to infinity mu star of A intersection EI. Okay, for all A subset of X. Put here, put A equal to X. Then what we get? Mu star of X intersection I equal to 1 to infinity EI equal to what? Summation I equal to 1 to infinity mu star of X intersection AI. Then what we write here? Mu star of union of I equal to 1 to infinity EI equal to summation I equal to 1 to infinity mu star of EI. Then what we get? We write here mu star be countably additive. Understand or not? I think easily understandable. So we also do this one. Okay? Not a problem at all. We also discuss one important property of measure theory corresponding to measurable set. Okay, so today we stop here.